All right, everyone, welcome. This is it, your final exam cram session. We're going to jump right into the high-yield stuff, the things you absolutely need to know to ace that biomedical research exam. No fluff, just the good stuff. So here's the plan. We'll basically walk through a whole research project, from A to Z. But here's the key. We're only going to focus on the tricky parts, the stuff that always seems to trip students up. Sound good? Let's dive in. Okay, first things first, we've got to figure out the who and the how of your study. Who are you actually studying and how are you going to pick them? We're starting with the population hierarchy, and trust me on this, it's always on the exam, so you'll want to pay close attention here.
Right, so at the very, very top of the pyramid, you have the general population. Think of this as the biggest group possible, like everyone in a country. We're going to use a study on PCOS, that's polycystic ovary syndrome, as our example. For that study, the general population would be, all people in India. It's massive, and honestly, you're almost never studying this whole group.
So from that huge group, we have to zoom in. This gets us to the target population. And this is where your actual research question starts to matter. It's defined by really specific things, clinical stuff, demographic stuff. Back to our PCOS example, we're not looking at just anyone. We're looking for females, specifically of reproductive age, who have a PCOS diagnosis, and they have dysmenorrhea. See? Much more focused. Okay, but let's be realistic. You can't possibly reach every single person in that target group, right? So that brings us to the next level down, the accessible population. This is the group you can actually physically get to. It's all about what's realistic, based on geography and time. So for our study, maybe it's just the PCOS patients who show up at one particular hospital's outpatient clinic, say between January and December of one year. And then, finally, from that accessible group, voila, you get your study sample. This is it. This is the group of people who are actually in your study, giving you the data. They're picked using a specific method, like systematic sampling, to get, say, 150 patients. So you see that. We go from this massive general population all the way down to a very specific, manageable sample. Now, this brings up a really important concept, a kind of push and pull in research. We're talking about internal versus external validity. Internal validity is all about how accurate your results are for the people inside your study. You get high internal validity with lots of control. But here's the catch. The more you control it, the less it looks like the real world, which hurts your external validity, your ability to generalize the findings. It's this constant balancing act you have to deal with. All right, let's keep moving. Now we're getting into the real blueprint of your project. We're talking about picking the right study design and, the big one, calculating your sample size. Okay, pens down for a second. Really listen to this one. Cohort versus case control. This is a classic exam question, and so many people get it wrong. It all comes down to one thing, time. Think of it like this. Cohort studies march forward. You start with an exposure and you follow people to see if they get the outcome. Case control studies look backward. You start with people who already have the outcome and you look back in their history to find the exposure. Forward versus backward. That's the key. So calculating sample size. It sounds intimidating, right? But it's not magic. It's just a step-by-step process. There's no secret number you just pick out of the air. You've got to walk through these 8 steps. Figure out your main variable, what kind of precision you need, set your risk levels, and then, this is important, you have to adjust for things like the study design and the fact that some people might drop out. You just follow the recipe, and you'll get the right number. And look, here's what that looks like in practice. Let's say you're doing a survey on how much protein people eat. You think the standard deviation is about 20 grams, and you want to be precise to within 5 grams. Okay, you just plug those values into the formula, use a standard 95% confidence level, and boom, the math tells you that you need 62 people in your study. It's as simple as that. Okay, so you've got your blueprint, but a plan is just a piece of paper, right? Now comes the hard part, execution. This is all about managing the project and, super importantly, designing really good tools to collect your data. For project management, I want you to remember this little mnemonic, HTFQDM. It sounds weird, but it stands for the 6 pillars: human resources, time, financial, quality, data, and monitoring. And here's a huge pro tip. A common mistake. Don't wait until the end to manage your data. You have to do it as you go in real time. That way you can spot errors and fix them right away, not when it's too late. And for your actual data tools like your questionnaire, use the voice framework. Your questions need to be valid, in a logical order, with clear instructions, coded from the beginning, and examined in a pilot test. The O for order is a big one. You always go from general questions to more specific ones. And any sensitive questions? Save them for the very end after you've built up some trust. Okay, here we go. This is what you've all been waiting for, right? The ultimate cheat sheet. We're going to boil everything down to the most important must-know comparisons. This is for that last-minute review right before you walk into the exam. So here are your main probability sampling methods, all laid out. Now, look at that column for design effect. This is the key takeaway for your exam. Notice how most are low or just 1, but look at cluster sampling. It's high, greater than 1. What does that mean? It means if you use cluster sampling, you have to pump up your sample size to make up for it. Forgetting that adjustment is a super common mistake. And here's the other big one, your study designs. This table nails that. It all goes back to that direction of inquiry we talked about. Are you moving forward from exposure to outcome? That's a cohort study, and you're calculating relative risk. Are you looking backward from outcome to exposure? That's case control, and you're calculating an odds ratio. If you can just remember that simple difference, you are in great shape.
All right, let's see if all this has sunk in. It's time for a quick lightning round quiz. No pressure. You ready?
Okay, first question. Let's say your list of people has some kind of hidden pattern in it. Which sampling method is most likely to get messed up by that? The answer is systematic sampling. You know, like if you're picking every 10th house on a street, but every 10th house happens to be a corner house, your sample's going to be biased. Next question. This is just pure memorization, folks. For a 95% confidence level, what's that magic Z alpha value you use in your calculations? It's 1.96. Just gotta know it, 1.96. Burn it into your memory.
All right, last one. A study starts by finding people who have a rare disease, and then it looks backwards into their past for exposures. What study design is that? That is a textbook case control study. And remember, they're perfect for studying those rare diseases.
So there you have it. You've got the blueprint, you've got the mnemonics, you've got the tools. But remember, a plan is just the start. The real magic happens when you execute it. A good plan prevents a poor performance. You guys are ready for this. You've got this. Now go ace that exam.